Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. La ilma lana illa ma 'allamtana. EI 3100 Mechanical Vibration Aerospace Engineering and Degree Program, Faculty of Mechanical and Aerospace Engineering, Institut Teknologi Bandung. Okay, in this season, I will explain about the introduction to mechanical vibration. Objective for our meeting. These lectures deal with systems having oscillatory motions, i.e. motion that repeats itself with time. This our objective. Jadi, so in this course or lecture, deal with system having oscillatory motions. Oscillation occurs in many systems, such as pendulum. Yeah, first, this first example, pendulum. Yeah, this frictionless pivot, and then meshless rod. This is meshes bob, and this is the bob's trajectory, and this is the equilibrium position. Yeah. Okay, the second example is a U-shaped manometer consisting of a fluid moving in a tube. Yeah. For example, this fluida is hydrargyrum, hydrargyrum, or waters. Yeah. And there is phenomena that the fluid will oscillate. And there are parameters, yeah, in this case, gamma, weight density, and then A, cross-section area, and then L is length of fluid, yeah, this one. Yeah. In this case, we can build the formula, yeah, for this case, and we can find the mathematical model from this phenomena. Okay, the third example is about moving of spring mesh system. This is for single degree of freedom example, and then this is a 2 degree of freedom case. In this case, for single degree of freedom, we have only one frequency. But for 2 degree of freedom, we will have 2 frequency, and we have 2 mode shifts. For first mode shift, 2 meshes move in one direction, yeah, like this one. And for second mode shift, 2 meshes move opposites, yeah, like this. So as the blue one downwards, the red one is upward. Okay, in this fourth example, it's vibration of continuous system. Yeah. This is a vibration of string, and this one is vibration of beam, and this one is vibration of airplane. Theoretically, the continuous system has infinite vibration modes. Yeah. Like this one, there is infinite vibration modes. Yeah. But in this slide, I only show 6 mode shape. Yeah. This is the first mode shape. This is the second. This third, fourth, fifth, and sixth. Yeah. Actually, theoretically, the string, the vibration of string, there are infinite, yeah, infinite vibration modes. For vibration of film, yeah, actually have infinite vibration mode too. In this slide, I only show 6 uh, mode shape. This first bending, first torsion. This is sec bending, first bending, and another. This is different different bending, yeah, different bending. This is the second torsion. Yeah. This is the first second. This is the sorry. This is the first torsion. This is the second torsion. And this is the vibration of airplane. Yeah, maybe it is a first mode shape. Yeah, mode shape mean shape when he vibrates. Okay, the next example is vibration or oscillation of guitar string. Yeah. If we have, if we give displacement, if we give displacement or initial condition, the string will vibrate and generates the sound. This is the electric electric guitar. Yeah. is the vibration or oscillation of electric guitar string are converted to oscillation of electric signal. So from vibration of string and then converted to oscillation of electrical signal, then cause vibration or oscillation in a speaker, which are then transmitted to oscillation or vibration of air molecule, and then propagates to our ear drum. Okay, the next example is artificial heartbeat. This is artificial heart, and this is support, yeah, maybe it's power here, and then give power to artificial heart, and then artificial heart will pump the blood. Okay, so uh, in biology we talk about vibration too. Yeah. Okay, the next example is our organ. Yeah. Our eye, head, heart, brain, etc. have mass and are associated with other organs with a certain elasticity and damping. So vibration phenomena will also occur. The vibration or oscillation that occur will also be damped, yeah, like this. Damped, yeah. So the amplitude is decreased. Okay, this is natural frequency or frequency of our organ. Yeah. For example, this is air. Yeah. It's about 30, 30 until 80 hertz. And then head, yeah, head have uh, 25 hertz, yeah, about 25 hertz. So every our organs have frequency, yeah, natural frequency. So it's important, yeah, it's important to design our tools, our cars, or our aircraft. Yeah, the natural frequency is not same with our natural frequency of our organ. Yeah. If same, there is resonance. Yeah. So our organ will vibrate high amplitude. Yeah. Yeah. Oscillatory motion has an effect on the body. Yeah. Okay. This is frequency. This frequency from 0, 1, 10, 20 until 20,000, and more than 20,000. Below 20, it's infrasound. If more than 20,000, it's ultrasound. Between 20 until 20,000 is audible sound, and this is potential discomfort. Is transmission part, yeah, from 0 until about 1000 is structure borne path. From 250 until ultrasound is airborne path. Vibration below until below 20 hertz, yeah, this is organ dysfunction. Yeah, it is nausea, yeah, disorientation, etc. Above 20 kilohertz is inaudible sound. Okay, is force vibration of the human body. Body in vertical or horizontal direction. Yeah. The system head, neck, shoulders. System abdominal, thoracic. Yeah. System jaw, skull, etc. Perception of sound, pain to auditory organ, damage to the auditory organs. This audibility, this pain threshold. This vibration, 20 until 200 hertz. Noise, 20 until 20 kilohertz. Okay, the next example is vibration of skin of aircraft. This turbulence, yeah, this computer simulation. This is for this KFX, EFX aircraft. We simulate using numerical. Yeah, we use Navier-Stokes equation. Its angle of attack 17 degree. Its angle of attack 19 degree. At a large angle of attack, turbulence will occur in the airflow around the aircraft. This turbulence will excite the skin panel and will cause vibration to the skin. This is Buffet phenomena. Yeah. We call this phenomena Buffet. buffeting. Okay, in the next example is offshore structure. Experience vibration due to continuous wave excitation. So if we design offshore, we have to calculate about the vibration. Yeah, it especially respond. Yeah, respond the structure due to the wave excitation. Okay, this is a mechanical vibration, uh, oscillation of mechanical system. In this lecture, we will focus on mechanical vibration, oscillation of mechanical system. So we don't talk about the human vibration. No, we don't talk about the biological vibration. No. Yeah. Mechanical vibration occur in system having inertia and elasticity. Inertia store kinetic energy and elasticity will store potential energy. This is a single degree of freedom case, and this is a continuous system. Continuous system. We calculate use finite element. Yeah. Damping from friction force, magnitude proportional to and directed opposite to velocity. Dissipate energy that will damp out the vibration when there are no other forces acting to the system. This is undamped oscillatory motion. Amplitude is constant. And this one is damped oscillatory motion. The amplitude will decrease to the time. Some vibrations are needed, yeah, like these tools, yeah. Ground compactor mechanism, yeah, ground compactor mechanism, loudspeaker, musical instrument, artificial jets is are some vibration needed. This one is ground compactor. Yeah. Ground compactor works by oscillating its body up and down. Yeah, up and down. However, the motion of handle, the motion of the handle should be small. Yeah, should be small, so that the operator can hold and control it without feeling tired. Loudspeaker, yeah, this is we need it. Diaphragm vibrates due to the electrodynamic force and produces sound wave. Okay, this is a loudspeaker. This diaphragma, yeah, this diaphragma. There is magnet, yeah, permanent magnet, and there is coil, yeah, coil. Yeah. So it can produce electromagnetic, electrodynamic force. Some vibrations are not desired. For example, vibration of car due to uneven road, and then vibration of aircraft due to the engine or turbulence, and then vibration of offshore structure due to wave. These are not desired. Offshore structure vibrates due to the continuous excitation from sea wave and current. Usually, if we design offshore, we design for more than 100 years. And the critical one is about fatigue. Fatigue due to vibration. Yeah. Vibration, if possible, minimize by isolating the source. For example, yeah, for our engine mounting as a vibration isolator. Effect of vibration. Yeah. There are many effects of vibration. First, yeah, disturbance of system functions. To avoid blurry picture, aerial camera mounted on an airplane must use vibration isolator to isolate it from vibration of aircraft structure. This is the picture about the camera mounted. Yeah, it's a vibration isolator. Yeah. Instrument of aircraft or cars should be mounted by considering the vibration level of the supporting structure. Okay, disturbance of comfort. Vehicle, yeah, for example, a car with excessive vibration level due to bad vibration absorber will cause the passengers feel tired or even motion sickness in some cases. This vibration may cause noise. Yeah. Noise is unwanted sound. Human tolerance to vertical vibration. Yeah. This is ISO. This is acceleration, and this is frequency or center frequency. It's time, yeah, 24 hours, 16 hours, 8 hours, 4 hours, 2.5 hours, 1 hours, 25 minutes, 16 minutes, 1 minute. Yeah. So we can tolerant with small, yeah, it's until 24 hours. It's for uh, low acceleration. Yeah, low acceleration. Okay, next. Fatigue of structure. Yeah. Vibration will cause repeated loads to a structure. High vibration level will cause fatigue of the structure. So fatigue uh, is caused by dynamic loads, and vibration is a dynamic load. Yeah. So vibration will contribute to fatigue. Yes, vibration induce fatigue. Yeah. Brand, brand, branch of steam piping to steam trap. Yeah, this is the fatigue due to vibration. Okay, modeling. What's the modeling? A car is supported by four wheels through suspension system. Important parameter: car inertial and suspension stiffness. Vibration of the car is analyzed using a model comprising a mass and spring. A damper (RC) can be added to the model to make the model more elastic than motion. So modeling is how to make a mathematic model. This is the car, yeah. The physical phenomena, and use the assumption, etc. We will we make a model, yeah, physical model, and from physical model we can make a mathematic model. Okay, so what is cost objective? Yeah. So our cost objective is introduce vibrational analysis of single and multi-degree of freedom systems. First, to understand the principle of mechanical vibration and physical parameter contributing in this phenomenon. And then the second, be able to calculate characteristics of vibratory system, yeah, like natural frequency and mode shift, and its response due to initial condition and external excitation. Yeah. And then the third course objective, be able to analyze in order to avoid unwanted vibration or to amplify desired vibration. These are our objective. Okay, then we talk about syllabus. Yeah. First, introduction. It's, we will take 1 week. We talk about oscillatory motion, vibration terminology, and this mathematics. Yeah. Second order ordinary differential equation, Fourier series. Yeah. We will review this one by uh, by um, homework. Yeah, there is two homeworks about mathematical. Yeah, so it's yeah, it's you have to conduct it, this homework. Okay, the second, yeah, we will uh, we will talk about free vibration of single degree of freedom. Yeah, free vibration of single degree of freedom. Yeah. We talk about vibration without input force, without excitation, and free vibration of single degree of freedom. We will talk about free body diagram, and then equation of motion, and then natural frequency, and then talk about motion to initial disturbance and damping effect. Yeah, we will take 3 weeks for this session, and then third, force vibration of single degree of freedom. Yeah, we will take 3 weeks. We will talk about equation of motion, unbalanced rotational, mass, and measurement. Okay, continue. It's content of lecture. Fourth, vibration with arbitrary force input. We will talk about response to impulsive and arbitrary excitation. Yeah. And we will use Laplace transform. And then we talk about response spectrum. 5. Multiple degree of freedom vibration. It will take about 2.5 weeks. Yeah. We talk about undamped 2 degree of freedom system, engine eigenvalue and natural frequency, modal analysis, multi-degree of freedom system, viscous damping system, forced vibration response, modal analysis, and Lagrange equation. And sixth, we will talk about continuous system vibration. Yeah. It's an introduction to structural dynamics. It will take about 1 week. And then the last one is aircraft vibration in the airflow. Yeah. It's an introduction of aeroelasticity. It will take about 1 week. Okay, these are the reference. Yeah, first, engineering vibration written by D. Inman, and then second is mechanical vibration with application written by Thomson, and structural dynamics, yeah, or continuous system. We will use structural dynamic written by R. Wright, and then we use mechanical vibration books written by Dan Hartog. Okay, these are our reference. I want to ask you to have in mind, yeah, this the main references. Okay, this is the last page. Lecturer rules. Yeah. Homework, pre-test or post-test will given every week. Practice assignment are given twice. Yeah. First is for 1 degree of freedom experiment, and then the second is 2 degree of freedom experiment. And then quizzes are given at the end of each chapter to check student understanding. And then mid-semester test, mid, mid-term test at week 8. Yeah. The material is introduction, free vibration, 1 degree of rhythm, forced vibration, 1 degree of rhythm. And then final examination at, at week 16. Yeah. The material is vibration with arbitrary force input and vibration of multiple degree of freedom. And then take-home test will give to you, and the material is about continuous system, introduction to structural dynamics, and introduction to aeroelasticity. Fluid, fluid structure interaction. Assessment, homeworks. The weighted is about 7.5%, and then quiz it's about 7.5%, practice assignment 15%, take home test or fluid structure interaction 25%, and then it's 25% is UTS, yeah, UTS, and then 25% is UAS. Yeah. Yes, homework is 7.5, quiz 7.5, yeah, is 15, and then 15, 30, 30, yes, still, yeah, 30, yeah, the take home test 20, yeah. Okay, I will check again. Yeah. A and B scores require that each component of the assessment has a value. Yeah. And then minimum attendance is 75%. Yeah. So you have to you have to uh, make attendance. Yeah. Fill attendance via via SIG, yeah, via SCX, yeah, SCX, academic etp.acid, yeah, and then you click kuliah, yeah, kuliah or lecture, and then uh, there is attendance, must you fill it, yeah. Okay, I think it's the last slide.